means that you are approximating a function with a function of degree 1. Okay, degree 1 means all variables to the power 1. In our class, linearization is going to mean the tangent line. You're finding the tangent line. So these same directions could have been written as find the tangent line. The reason why there is a second vocabulary word that kind of means that same thing is because in Calculus 1, we are working with two-dimensional functions, meaning you're plugging in one variable, you're getting out a second variable, and we graph in what is called R2. It's called R2 because your x-axis is a real number axis, your y-axis is a real number axis. You have two dimensions in the set of both the set of real numbers. But if you were in higher dimensions, there are linearizations that go along with those other dimensions. So, for example, if I have some surface in R3, R3 means the 3D space where your x, y, and z are all real number axes. And I wanted to approximate this surface near a point with a linearization. That linearization is going to be a plane. The equation of a plane has all variables raised to the first power. So it's a 3D version of a line. If your surface is an R4, which we can't draw a picture of R4, you just have to kind of think about it, then a linear R3 surface is the linearization of your R4 surface. So it would be some three-dimensional, or a four-dimensional, you'd have a four-dimensional equation where all the variables are raised to the first power, and that four-dimensional equation with all variables raised to the first power would be your linearization of your four-dimensional surface. A lot of times people think about R4 as R3 with motion. You can sometimes model it that way, but not necessarily. So that's the reason why the directions don't just say find the tangent line. In Calculus 1, we could write the problem this way, but they're trying to kind of gear you eventually to other dimensions. So the same idea applies in other dimensions, hence we have another word that can span any dimension. So right now we're in Calc 1 though, and we're still working in R2, so we will find the tangent line. So to find the tangent line, we want to find the derivative because it gives me the slope of the tangent line. And so in this case, we'll do power rule, so I'll multiply by 3/4, and then I will subtract 1.
Negative 1/4.
Negative 1/4. And then we want to plug 16 in. So 3/4 times 16 to the minus 1/4. And negative means reciprocal. And the book often writes these so that the numbers work out nicely. So 16 to the 1/4 should be 2, because 2, 4, 8, 16 is my fourth power. So we get 3/8 is my slope. Okay, so that's just the slope of my tangent line. You guys did a couple of tangent lines on other things I've given you to do. So now to finish finding the line, we want the point on the actual original curve. So f of 16 is 16 to the 3/4, which is 2 to the 3rd. Is everybody okay with where I got 2 to the 3rd? It's 16 to the 1/4 and then cubed. 16 to the 1/4 and then cubed. All right, so that means that y is 8 when x is 16. Or you could do your point slope form, but just don't forget to finish it off. So what do we get? 2 equals b, I think. Because 8 divides into 16 to get 2, and then 3 times 2 is 6. And then subtract, and you get, so y equals 3/8 x plus 2. All right, that's the linearization, and what I brought up the calculator on the computer screen, and I'll turn on the